This is a combustion reaction where we have butane gas reacting with oxygen gas and producing carbon dioxide and water. Because butane does not stay together in the chemical reaction, we have to look at the carbon and hydrogen atoms separately. So let's start by determining how many atoms we have. We have a total of 1, 2, 3, and 4 carbon atoms. We have 3 plus 2 plus 2 plus 3 gives us a total of 10 hydrogen atoms. And then I have 2 oxygen atoms. On the product side, I have 1 carbon atom. I have 2 hydrogen atoms. And I have 2 plus 1 gives me 3 oxygen atoms. Now, we need to identify the loner. And that is the one that is not part of a compound, so that would be oxygen. And the loners, we want to leave them last in the chemical equation. So let's work everything else and let's leave this last. Next, we need to identify the 1:1 ratio. It happens to be that carbon, it appears 4 times in the reactant side and only 1 time in the product side. Hydrogen, the same thing. It appears 4 times in the reactant side and 1 time in the product side. Oxygen, it appears 1 time in the reactant side and 2 times in the product side. So therefore, we cannot identify the 1:1 ratio. That would be the one that appears 1 time in the reactant side and 1 time in the product side. And it does not matter if the subscripts are different. So since we cannot identify the 1:1 ratio, that means we cannot start with the largest 1:1 ratio. And that would be the one with the largest subscript. But one thing that I do know is that we are leaving the loner towards the end. So I'm going to leave the oxygens towards the end. And I'm going to focus on either carbon or hydrogen. You can start with either or. I'm going to start with hydrogen. So I have 10 hydrogens here and I have 2 over here in the product side. It's much easier to turn this 2 into a 10 than it is to try to turn this 10 into a 2. So what I'm going to do, I'm going to lock this compound with a 1 so that I can still have 10 hydrogens. And then I'm going to come over here and I'm going to turn this 2 into a 10 by doing 5 times 2, which gives me 10. So now our hydrogens are balanced. In the past videos, specifically those consisting of polyatomic ions, I usually ask the question of where to continue. And usually the answer is to continue with the one that is going to make the biggest change. It usually is the bigger number. But in this occasion, because this chemical equation is different from the rest, I'm going to start right here. I have a total of 1, 2, 3, and 4 carbon atoms. Even after putting the coefficient of 1, I still have 4 carbon atoms. So I'm going to come over here and I'm going to write a coefficient of 4. And now my carbons are balanced. Next, I need to know how many of the oxygens I have. Now I'm going to switch myself to this side of the chemical equation. Why? Because I already have my coefficients, at least temporarily. So let's find out how many oxygens we have. 4 times 2 gives me 8. And then 5 times 1 gives me 5. 8 plus 5 gives me 13. So that means over here in the reactant side, I need to have a total of 13 oxygen atoms. So what I can say is 2 times what number will give me 13? 2 times 6.5 equals 13. So I'm going to write my 6.5 here. However, I cannot have coefficients being decimal numbers. So the rule is to start out by putting parentheses and multiplying everything by 2. So this 2 is going to be distributed to all of the coefficients. So I'm going to erase all this now. Either way it's going to change. 2 times 1 gives me 2. 2 times 6.5 gives me 13. 2 times 4 gives me 8. 2 times 5 gives me 10. Now I'm going to rewrite this neat. Then I have over here 13. Then I have 8. And then finally I have 10. Now let's see if this equation is balanced. So I have a total of 2, 4, 6, and 8 carbons. And I have a total of 2 times 3 gives me 6. And then 2 times 2 gives me 4. 2 times 2 gives me 4. And 2 times 3 gives me 6. So once you add all this up, you're going to get a total of 20. So we have 20 hydrogen atoms. Now, on the product side, we have a total of 8 carbons. We have a total of 10 times 2 gives me 20 hydrogen atoms. And last, we have the oxygens. I have 13 times 2. 3 times 2 is 6. 2 times 1 is 2. So I have 26. And on the product side, I have 8 times 2, which gives me 16. And then I have 10 here. So everything is balanced. So you should have for coefficients 2, 13, 8, and 10